Hello, my dear student. I'm Saktwala from Educare TZ. I will be with you in physics for Form 5. And today, my dear student, we are going to proceed with our topic of the properties of matter as we tried to see on the last lecture. Now, today we are going to proceed with our subtopic, which is called the surface tension. Now, let us go and proceed where we ended on the last session. So, on the last session, we ended on how we can define the surface tensions. We tried to see the concept about the surface tension. And after there, we imagine that we have the two lane drops, and that we have the two atoms, and that atom, my dear student, attracting each other. If they attracting each other, it means that they provide the force of attraction that give us the work done that occur between those atoms or molecules. We say that we should obtain the work done by taking the negative small change of by taking we get the work done but equals to the force times the small distance, and we simplify the more and obtain that in terms of the potential energy, we should obtain the change of the potential energy, which is equal to negative. It means it must be equals to negative of the change of the work done, and we simplify the more, we obtain that must be equals to negative must be equals to negative f r change of r. But for the limit, it means that when the distance is very, very small, we get the force by taking that force must be equals to the derivative of the negative derivative of the potential energy with respect to r. This is what we tried to see on the last session. So on our today discussion here, we are going to look about the measurement of the surface tension. How can we measure the surface tension? It's what we are going to learn for our today discussion. So as we see here, imagine a tangential line AB draw on the surface of the liquid, dividing the liquid into two parts as is shown in figure number 4 for our 6 topic here. Kwamba tuashumu we have the liquid, and that liquid, my dear student, contain the tangential line. This tangential line AB is drawn on the surface of the liquid. Is drawn on the surface of the liquid, dividing those liquid into two equal parts. This as it is shown in figure 6.4. So this is our liquid here, my lovely students. We have our liquid, our atom. As we see here is the liquid as it is shown here. The figure explaining the measurements of the surface tension of the liquid. Kwa figure yetu inajaribu kuelezea measurements ya hii measurements of the surface tension of this liquid as we observe here. Now we have this figure, and this figure, my dear student, involve the liquid. We have point A and also a point B. So on point A, this is the line, the tangential line that dividing the liquid into equal parts. Kuna liquid ambayo itapatikana below here, and there's the liquid that could act upward as we observe. But at the center of this line, we have the force. This force is formed due to the perpendicular line. It formed at 90 degree, kwamba ni line ambayo ina act perpendicular with this tangential line as we seen here. Kwa kuna force yetu ambayo imeact kama tunavyojaribu kuiobserve hapa. Now the two parts of the surface of a liquid act like a straightforward membrane. Kwa ile two parts, the parts the two parts of the surface of the liquid, the upward parts and also the downward parts, my dear student, could act like the strategid membrane. Why we say that could act as a strategid membrane? This is because within the force pulling along the any line on the surface, these forces are proportional to the line, proportion to the line's length at the perpendicular to it. Kwa nini tunasema? Kwa sababu yule force aliye act pale ameokaa perpendicular, kwamba yule anavuta kuelekea juu, lakini kuna force mwingine ambayo anaweza kiexert pale downward. That means kwamba there is the force of attraction that separating those liquid into equal parts, as we tried to observe on our figure there. So let F be the magnitude of force. Imagine F should represent the magnitude of force that exerted on each other by the two parts of the surface across the line segment. Kwa yule F atakuwa ni magnitude force. Kwa nini tunamsema ni magnitude force? Kwa sababu ni force ambayo ana exert on each part of the two parts. Kwa ni force ambayo ana act on the two parts, as we tried to see, of the surface across the line segment AB. Kwa yule force ambayo ata act across the line segment AB, as we seen on our figure there. Now the surface tension, is the force per unit acting in the surface of the liquid perpendicular to the side of the line of that here. So we define the surface tension mathematically. If we leave from our definition that we know that surface tension is the ability of the liquid to behave like the full straightly elastic skin. But in mathematically, we could use that figure number 60.4 so as to demonstrate the formula related on how we can calculate the surface tension. And we see that from that figure, we obtain the surface tension by taking the force per unit the length acting in the surface area of the liquid perpendicular. So let us turn back for our figure here. The aim for having this one is to get the meaning of the surface tension. Kwa ituweze kupata surface tension, tumeambiwa kwamba we should take the force is the ratio of the force acting from the line. It's the ratio of the force acting per unit at the length AB, per unit the length of the line AB that is separating the liquid. As we see here, my dear student, this here will be our definition. Kwa utadefine surface tension kwa kuchukua yule force divided by length, as we see here. So the symbol of the surface tension must be represented by this symbol tunavyoiona hapa. Kwa hiyo ndio symbol ya surface tension, ina muundo kama wa Y hivi. Kwa symbol yake ni this one equals to the force per unit perpendicular line acting on that force of the surface of the liquid, where this F represent the force on either side of the liquid, on either side of the line segment, and the I and the L become the length of the line of the length of the segment. Kwa sasa tutamwambia huyu F anamaanisha either ni force ambayo ata act on the side of the line segment AB. Kwa kama ata act kwenda juu au kama ata act kuja chini, ndio ile force ambayo tunamzungumzia sana. But this L, my dear student, be at the line segment of be the length of the line segment AB. Kwa hiyo atakuwa ni length of the line segment AB, as we seen here. Now let us go and see the sign of this surface tension by using the dimension. Tujaribu kuliko dimension ambayo itaweza kututengenezea sign of this surface tension. So the dimension of the surface tension is given by this one. How can we get the dimension of the surface tension? Let us come back for the formula which says that surface tension is equal to the force divided by L. Now introduce the dimension throughout for each value. If we introduce the dimension, we should obtain that the dimension of the surface tension must be equal to the dimension of the force, then divided by the dimension of the length. But we know that the dimension of the force must be equals to ML, must be equals to ML at t negative t power negative 2, lakini dimension wa L atakuwa ni sawasawa na yule L dimension wa length. Kwa tukisubstitute pale tutakuja tupate kumbe surface tension must be equal to ML t exponent negative 2, then we divide it by L. But here we have L throughout. Kwa kama tuna L, unaweza kutumia ile concept ya exponent kwamba if we have the same base we are supposed to minus their exponent. Kwa tutachukua huyu L aliyeko juu kwamba exponent wake ambao ni moja, tukimpandisha juu atakuwa ni negative, basi tutakuwa kwamba ni ML power moja minus 1 times t power negative 2. Yule L ataisha, tutabakiwa sasa ni sawa na mt power negative 2 as we seen here. So this the dimension of this surface tension must be equals to mt power to t power negative 2 as we seen here. This m is the mass and also t is the dimension of the time, where this could give us the unit which is Newton per meter. Kwa unit ya surface tension itakuwa ni Newton per meter as we seen here, my dear student. This will be the unit. So after there, let us go and conclude here.